Okay. Well, thank you all for joining us. My name is Hannah Phillips. I'm on the board of the Field Naturalist and Ecological Planning Program Alumni Association. And this is the second in our spring webinar series featuring the work of the alumni of the University of Vermont Field Naturalist and Ecological Planning Program. The Field Naturalist program is a graduate program at the University of Vermont that since 1983 has recruited students with the moxie to break new environmental ground. Simply put, the mission of the program is to develop the next generation of conservation leaders. Our graduates are sought after leaders in stewardship, conservation, policy, ecological planning, and place-based education. Whether they work in boardrooms or bogs, field naturalists stand out as holistic problem solvers. Over 90% of alumni in the program have careers in the environmental field, and nearly half go on to lead major conservation initiatives in public, private, or nonprofit organizations. But as we approach nearly 40 years of the Field Naturalist program, we realize that with alumni working in 30 states and 7 different countries, we actually have a yet unexplored opportunity to strengthen our network of conservation practitioners around the world. So with that in mind, we formed the Alumni Association in 2017 with an explicit goal of reconnecting these individuals to one another and to their work. Our hope is that by building this alliance of modern conservation practitioners, that we can encourage collaboration to confront the environmental challenges of our time. Since our founding in 2017, we've organized conferences and gatherings in Vermont. However, it took this global pandemic to force us out of our comfort zone and into the digital sphere. And while we're sad not to host our in-person symposium in Vermont this year, we're really glad to be able to feature the work of our alumni around the country. So hopefully some of you were able to tune in last week for our first presentation by Tess O'Sullivan with the Nature Conservancy Idaho. Today we're really excited to have Anya Tyson join us to talk about Tracking Timber, a Tree-Part Story. And we have 2 more presentations coming up after this with Catherine Hale, who lives in North Carolina, and Jesse Griffin, who lives in Oregon. Our presentation today is by Anya Tyson, who's calling in from Bend, Oregon. She's a proud Goshawk, meaning she represents cohort AG, Accipiter gentilis, graduating in 2017, and is a self-proclaimed northeastern know-nothing, but she got her money's worth as a field naturalist. Presently, Anya works to collaboratively improve land management across Oregon's sage-steppe for the Nature Conservancy Oregon chapter, along with field naturalist alumni Jesse Griffin and Matt Cahill. Previously, she led citizen science projects involving bigleaf maples, loons, and Clark's nutcrackers. Tonight, she'll be talking to us about a project she organized for adventure scientists, training and deploying a cadre of conservation scientists to collect data from remote locations in order to track bigleaf maple timber poachers. So before we launch, please make sure that your microphones are muted, but we're going to encourage you to keep your video on so we can see you laugh and smile. If anyone has tech issues, you can put them in the chat. Tate will be in the chat room attending to those, and you can find those controls at the bottom of your screen. So now I'm going to turn the screen and mic over to Anya, and she's going to take it away.
All right. Just to help orient you, I'm currently in Oregon. In my background, you see like the Pacific Northwest rainforest. I live on the dry side of the state now and now work in the sage-steppe, but I grew up in coastal Oregon, and the story I'm about to tell you mostly takes place in the Pacific coastal forest. So what you see behind me. All right, diving into it. So tree-part story, and I'm gonna start with the roots as the first tree part. And the roots in this situation is the context of why adventure scientists launched into this big project that I'm going to tell you about. And it starts in a pretty sobering spot, which is the illegal timber trade. And up to 30% of wood on the international market has been illegally harvested. And it's an ecological disaster globally. It wrecks biodiversity, it exacerbates climate change, and something that I wasn't super familiar with is that it has really big implications for human dignity and social unrest. And just to give you a sense of how big the illegal timber trade is, this is the high estimate, is that it's about $100 billion are moving around the global economy on illegally harvested timber products. So that's comparable to the illegal drug trade around the world and dwarfs the wildlife trafficking trade. And yeah, I was talking about a little bit about the social implications of it. In some regions, it's really stark. You know, guns are coming in to support militias and pretty unsavory concentrations of power, and wood is coming out of that area. So it's really tied to civil unrest in certain areas, unfortunately. And you know, that's not the cheeriest, bright thing, but if you were like me a couple years ago, you maybe thought about illegal timber trading in your savvy FN network, so you probably knew about it to some extent, but if you were like me, you maybe thought like, oh, that happens in different countries, not in my backyard. That was my misconception, probably in 2016, that's what I thought. In early 2017, this cool article came out in High Country News, which covers the West, and it revealed to me that there is actually a lot of timber trespass happening domestically and specifically in my backyard. So a tree that's being targeted here in the Pacific Northwest is the bigleaf maple. And the bigleaf maple was the star of my 4th grade leaf collection. You know, I grew up in coastal Oregon. This is a tree species in my backyard, and I had no idea that it was being cut down on the sly and sold into a lucrative wood trade. And what happens out there is, so not all bigleaf maple is at risk to be cut down. For it to be valuable for timber poachers, it has to exhibit figure. And this is this property that's reflective and shimmering and can be made into instruments and beautiful wood products. And not all trees, only about 1 in 10 maple trees, bigleaf maple trees, exhibits this property. And so what happens in the Pacific Northwest, you know, there's a lot of areas with not a lot of people in them. And somebody who's looking to make a quick buck and has, you know, doesn't want to follow the rules, will go out into the forest with a chainsaw, and they'll first check trees to see if it has the wood that they know will fetch a high price, up to over $200 for a square board foot. And if they do find a tree that has figure, they will try to take it out of there when there's not much activity, whether it's in the dead of night or an off season. And, you know, first, bigleaf maple, you could get permits to take it out because it wasn't initially a very commercially valuable timber species like some of the other trees in the Pacific Northwest. But then the ones that you could legally harvest got a little slim picking. So all of a sudden trees started disappearing out of people's backyards when they went on vacation and out of, you know, national parks up to and including. So why did this happen? This wasn't happening a couple decades ago. Well, 3 decades ago, but starting in the early 2000s, this is where Santana comes in. So now I don't mean to, you know, slander Santana's character. I don't think he personally poaches or endorses poaching, but he was a key player in this because in the 2000s, he got famous. He won a Grammy. He performed at the Grammys with Rob Thomas. You know, the song Smooth. I don't know if you all were tuned into late 90s, 2000s music, but like, down, up, down, but he played this on a bigleaf maple figured electric guitar at the 2000 Grammys. And the interest in this type of guitar skyrocketed and the poaching rates crept up. So that's where Santana features into this story, in case you were wondering. But bigleaf maple, why do we care in some ways? Because I know this is an astute audience, and maybe you heard like, well, only 1 in 10 trees actually show those cool properties. And, you know, maybe it's not that big of a deal if 1 in 10 trees get snatched in the big scheme of things, considering we have a lot of big fish to fry ecologically in this world. But, you know, I don't think I'll have too tough a time making a case for the bigleaf maple. This tree is pretty special. And there are not tons and tons of deciduous trees in the West. There are a lot more in the East. And so this is really important habitat to songbirds. And in the Pacific Northwest, this tree has a really neat feature in that it can support like 2 to 3 times its own biomass in epiphytes, so in mosses and ferns, and it creates all these neat microhabitats for little creatures, up to and including the Puget Oregonian snail. It's a species at risk that's formally listed in Canada, and I believe its status in the US is warranted but precluded. So each time an old growth tree leaves our forest, even if it's not a wholesale clear cut of a forest, as in some of the hot spots for illegal logging internationally, we lose some really cool habitats, and we lose a whole bunch of carbon that was effectively stored in essentially an old growth tree. So what's the upshot of this? What tools do we have to combat the illegal timber trade? Because the crux of the illegal timber trade is a piece of wood looks like a piece of wood, looks like a piece of wood, looks like a piece of wood. It's not like a tiger pelt, you know, where you're like, ooh, there's a problem with that. I know that we have an issue on our hand. It's really easy to get, you know, oh, this wood was legally harvested and we got some great paperwork for it. And now we can just slip this other wood that was illegally harvested in with that shipment. It's really tough to look at wood just visually and know whether it was legally or illegally harvested. But there's these suites of technologies that help, that give law enforcement officers and governments tools to address that. And they're called wood identification technologies. And one wood identification technology, a couple of them rely on genetics and DNA. And SNP SNP stands for single nucleotide polymorphism. So if you map a genome with something, you can figure out little spots that kind of reliably show some variation, and you can sometimes tie that variation to geography. And often you can tie it. One way that DNA has been used successfully to crack timber poaching cases has been to find the site where the logs were cut, take DNA from those logs that were cut, find the mill that you suspect is operating shadily, accepting cash, like trading cash for timber in the dead of night, find blocks of wood there and match the two together using DNA fingerprinting. That's when you can pull that off, it's really successful, but a lot of pieces have to come together for that to work. So there's this other approach of using DNA, not just to tie specific stumps to specific pieces of wood, but to tie wood of unknown origin and suspicious origin to its geographic location. And there's some neat, these are kind of dense graphics, but there's some neat ways to, instead of having to map the entire genome and find these kind of repeatable single nucleotide polymorphisms, there's these new genetic approaches which kind of use informatics to take a whole bunch of genetic information and map out commonly occurring sequences. And that is also really promising for tying things to geography for certain species, and requires a lot less infrastructure, so less investment per species, which is really interesting. Then there's also mass spectrometry. So I am not an expert in that, DART, time of flight mass spectrometry, but essentially you shoot a bunch of ions, helium ions at a piece of wood, and you, when they bounce off of the wood, they produce different chemical signatures, and that can be useful for tying, at least getting things to the right species, because sometimes in the legal timber trade, you know, right now, like all rosewood is in question of like whether you're allowed to trade it. So if I can at least say, hey, this is rosewood from a certain country, you could be in trouble. I don't really need to know much more than species and really, you know, maybe that it comes from a certain continent. But another, so dark time of flight mass spectrometry might also be really useful for tying things to more specific origin. The issue with all these technologies is they all rely on a very complete set of reference specimens that encompasses the entire range of a species, which is pretty difficult to get. And that's where this project came to be. So I'm kind of wrapping up the roots and the context of this project. These are all various entities that came together and said, hey, we would like to do a proof of concept project. Can we use citizen scientists to get an entire across the range research grade specimen collection to fuel our various technologies? And this effort was funded by and large through Norway's International Climate and Forest Initiative. That's kind of interesting, like why was Norway spending money on this thing in the US? Well, it's because Norway believed this is a testing ground, this is a sandbox to see if this approach works in geographies that we actually are really interested in as a, a developed nation that knows that we need to change the tide on our warming planet. So they're like, we're gonna fund this with the eye of, you're gonna learn lessons here in the US that then we can apply to, places such as Indonesia and Brazil. And so Adventure Scientist was the organization I was working for at the time that said, all right, we're gonna do this. We accept the challenge, we accept the funding, we're gonna get you your range-wide reference collection of bigleaf maple. And so here's where we come to our next tree part, which is the roots, not the roots, the trunk and the branches, the structure of how this project came to be. Not just the context, but what were the bones of this project. So Adventure Scientists agreed that we would get 1,000 different sampling locations. We would get samples from 1,000 different locations that represented the entire range of this species. And here's, on the right here, you see the range map that came from Silvix of North America. And I'll just say, it is wrong. So this is what I was initially working with, but luckily I checked some references, and you can see that on the right, that range map extends way up into British Columbia. But in reality, the range of bigleaf maple only is found pretty much to the northern tip of Vancouver Island. If you draw a line out on that latitude, you can see it gets up there, but not much further. And I'm really glad I figured that out, because it would have been big waste of resources had I sent volunteers up to really remote parts of like Prince William Sound, and there were no bigleaf maples there. So this was my goal on that. They hired me on, they're like, we have this money, we have this task, like you need to make it so, Anya. And so I was like, all right, where does this species grow, and how am I gonna ask volunteers to get where they need to go and collect what they need to collect? So the first thing I did is I used QGIS, of all things, to create leaf sampling zones. So I created this grid over the range, and I created 62 kind of volunteer management zones. And each of these little squares had different targets of how many trees people were aiming to sample from within their square. And volunteers would theoretically sign up and be like, I'm gonna cover leaf zone 20. And we did have kind of two different tracks for volunteers to take, because I realized, a lot of what we needed were leaves. And that was pretty simple to train people. Like, this is what you need to do. You need to get a leaf from the tree, you need to put it in a little envelope, take a few notes, put it in some silica desiccant, and you're good to go. But that wasn't all we needed. I mean, leaves gave us a great genetic database, but we also wanted wood, because a big crux of this whole wood identification technology realm where it relates to genetics is you need to be able to successfully extract DNA from wood, which is not easy. And so we needed cores and cross-section of branches and leaves, and we needed a botanical reference specimen to be housed in an herbarium. So that was pretty fun. So for a smaller subset of volunteers, I was like, all right, you're the special ops team. You're not just getting leaves, you're learning how to take a tree core, you're gonna have a big saw and gonna try to get cross sections. And I really got to use some of my FN skills, because I taught that crew of people, the wood crew, all about how to make, how to press plants and the information they need to collect to furnish a good botanical herbarium reference specimen. So I had to think about, okay, what's all the gear that I need to send out with people? Here's an example of the gear that the wood crew needed. And beyond that, I needed to think of a lot of infrastructure. So we used a couple different apps. And on one side of the screen, you see the Magpie app. So I didn't develop an app specifically for this project, but Magpie has kind of a data form that's really manipulative, that you can manipulate to your needs. So I created a whole suite of questions that not only got the information we need, but hopefully prompted volunteers to not forget very important steps of the process. And then also, and here's some examples of those screens. So You can see leaf crew and wood crew screen. And the nice thing about an app is there's no data transcription errors, and you can kind of keep things higher quality in terms of data sets from the beginning, because people can like realize they can't go on to the next page or can't press save if they left something out, rather than when they get back from the field. I'm like, oh, I didn't fill that out. No, I don't remember. And in the middle of the screen, you see, I also created volunteer safety was a big issue. You know, we're like, okay, we want to go to 1,000 really remote places. Not all of them are remote. Some are pretty, you know, in people's backyards. But when we're sending folks to remote places, we need to make sure they come out of the field safely. So I created this Google based, it was a product that is available to anyone, that was designed for teachers to be able to check in and out, like let's say an iPad. And I rewrote that so it was check in and out of volunteers. And it had some glitches since it was open source, but it actually worked pretty well as a way for volunteers to check in and out and get automatic prompting if they didn't check in and out. And the issue only be elevated to my notice when everybody ignored the prompts to check back in. Something else, I don't know if you noticed when I shared that equipment photo, you might have seen some bleach and some 409. A big part of setting this up was realizing like, okay, we are across a big geography and there's different issues across that geography. And one issue was that in California, there's a pathogen known as sudden oak death, and bigleaf maple is a host plant. So I needed to not just think about volunteer safety, but I need to think about environmental safety. Like it would have been a PR nightmare if you know, my volunteers were responsible for spreading this pathogen. So we really thought a lot about like, okay, here's how we're going to teach everybody how they clean stuff, and we're going to have these extra layers for volunteers in these California leaf zones. That was a whole nother hurdle in setting this all up. Similarly, you can imagine that it would have been really, really bad press if the project ran into the situation where, you know, we were poaching in the name of preventing timber poaching, because I was sending people out all over the place. And so I really worked very, very hard. A ton of legwork went into getting permits from so many entities, and it took months and months. We started this in February thinking like, oh yeah, we'll get people in the field in April. We didn't get some of our permits into July, and some permits we never got, but we did our best to get as many permits as possible. And then we also showed folks, we had used Gaia GPS because you can pull up ownership layers. And so we made it really clear to folks that they needed to cross their T's and dot their I's in terms of making sure that they were on the correct ownership land and they had their permits in hand for where they were going to sample. And all of these different structures I set up were communicated to people via online training courses. And this is where the connection to the current moment is pretty interesting because Adventure Scientist is based in Bozeman, Montana. There are no bigleaf maples there. Bigleaf maples occur all along the coast. So this really, when I came into this position, I was excited to be in Bozeman, Montana, because it was pretty close to Wyoming, that I really, really love. But I was pretty confused because I was like, all right, I've done citizen science before, but I heavily relied on my ability to pull out an accordion and sing a goofy song to motivate my volunteers and to meet them in person and to shake their hand and like give them, like feed them and like buy them beers and stuff to thank them at volunteer appreciation events. Like how was I going to do this now that I was hundreds of miles away from my nearest volunteer? And the first lesson there is you definitely still play the accordion. I'm gonna share with you something that I'd send my volunteers off to take the online training, or they'd apply after we found them on social media with a bunch of advertising, and then they'd take our training. And then after the training, they'd be prompted to come to a webinar where I could answer their questions in real time and like start to create a relationship with them, even though it was digital, because relationships are really kind of a currency that fuels citizen science projects in my experience. And so if you're just joining us, maybe some folks have joined late, this will serve as a good recap, a musical recap of why the heck the Timber Project is around. And I have to thank, I already featured one pop culture icon of Santana, but we're bringing another one to light right now, and that is Kesha. Kesha is, I'm very grateful to Kesha because I may have stolen the entire melody and most of the words of the song from her. It's going down, legal timber. We're using science to stop the theft. We need you to get the samples. We've got geneticists to do the rest. They'll build a database that can show where timber comes from, and so we'll know who's going down for stealing timber. We're using science to stop the theft because the maples in our parks belong there, not in guitars. Yeah, so that was involved in webinars, and it was good to see you all chuckling, because that's the point. To realize, like, to let folks know, like, oh, this is this thing that's going to be fun. You're going to donate a lot of your time and energy to it, but we're going to try to make it as fun as possible. And, I never did get to host an in-person volunteer event, but I hosted a happy hour webinar at the end of the season. And in general, we used a lot of webinars, and not just like, we used a meet and greet webinar up front with smaller groups, but then we hosted like a conservation careers webinar as a way to motivate our early career participants. And we hosted, we kind of offered our volunteers like behind the scenes VIP experiences. We had a great meet the scientist session, and all of this culminated in a happy hour webinar that actually happened. So, I mean, now you see this, you're like, happy hour webinar, happy hour Zoom, those are dime a dozen, but it was a new frontier for me back then. And so I'm coming to kind of some of the later tree part, the last or second to last tree part, which is the leaves. It's great, trees without leaves are all right, but us folks who have lived in Vermont know it's a whole nother dimension once the leaves are on the trees. So what came of this effort? I'm happy to say that we succeeded and did hit 1,036 sampling sites. So here's this ridiculous little animation of the sampling sites popping up everywhere. And it happened slow at first, and a ton happened in September, right before the curtain closed on the field season. And it was a very big sprint for myself and my volunteers that really gave so much to this effort. So we all said and done, we had this many leaf samples and this many wood collections. If you're real quick with numbers and you notice a discrepancy there, and it's because between the last slide and this one, that's because we did lose some samples in the mail, which will happen. But beyond those samples that we created, we created this network of really cool advocates for the subject that had walked the same journey that I walked, which was like, timber poaching, that's a thing somewhere far away, right? No, it's happening right here. And you have some influence over that, both as a citizen scientist, but also just as somebody who's aware of it. So you're like, you kind of are more discerning of a consumer and a voter, and you're just aware that that's an issue out there in the world. And that's kind of a neat thing about citizen science. It's certainly not free. That's a big misconception about citizen science. It takes a lot of resources, but you can get an end product of a data set or a sample collection set, and you generate a network of concerned citizens. And one volunteer I'd like to call out really quickly, I did get to meet a couple volunteers in person. I wish I should have picked a photo of his face, but Renee and Giselle Guerra were these really cool Brazilian volunteers from LA. And I got to meet them in Bozeman because their son was going to Montana State University, and they're really special people that I'm still in touch with. And they were actually featured, PBS did this cool little documentary on the illegal timber trade, and they focused on these two volunteers and did a little segment, and I'll share that in the chat window later. They're very special people, and it was kind of neat that they they came from, they grew up in Brazil and now live in the US. And so they know two different sides of this story and are super engaged and passionate people. And I wanted to mention that I wanted to bring the FNs in the crowd to the place. I did a lot of this remotely, but I'm happy to say that I got to visit the range of bigleaf maple on a couple of occasions. I went to Southern California in March to grab some media for this project because I need to create all these online trainings and I need to have actual photos and videos of all the stuff I was asking people to do. And then late in the season, we did not have a ton of volunteers in rural Northern California. People call like the Bay Area Northern California. California goes so much further north, and there's so many wild landscapes in that part of California. And I drove across them and did this ridiculous sampling push at the end, which was really great that I got to do some field work, and it was really empathy building because I did what I asked my volunteers to do. And in terms of landscapes, it was pretty cool. This is a bigleaf maple, believe it or not, in the Mendocino Hills where it's super dry. A couple bigleaf maples were like in bonsai status because they were really heavily browsed by deer, and so they looked like this with tiny little leaves and tiny little statues. This bigleaf maple is smaller than my knee. So that was pretty exciting to see it in its full expression because it also can get this big like the one behind me. And I also, which was sobering, drove through Redmond, which had an urban wildfire where, the urban wildland-urban interface had been faced with a devastating fire. And that was a really big challenge of our sprint of the field season. Was our biggest data gaps, you can see in this portion of California, were in Mendocino, where the Mendocino Lakes Complex fire was one of the biggest in California history, which was a big doozy for folks. And there was a lot of folks who not just couldn't go out to a certain area because it was closed, but some of our volunteers were evacuated out of their homes. It was a serious fire season, and it was really sobering for me to see that firsthand. And I also got to go to the redwoods in the Siskiyou region. And once again, some of you folks might be more based in the east, but the Klamath-Siskiyou region is really, I think it's the highest conifer diversity in the world right there. So as the maples there, it turns out, are genetically distinct. And it was a really cool region to explore, even though it was kind of a whirlwind tour. And I topped off my trip with a visit to the redwoods. And this tree is a famous bigleaf maple. It's called the rainbow tree. And it appears to have two sets of roots. It's rooted on either side of the trail across this arch. And it's a famous bigleaf maple tree. It's actually rooted in 3 places. And they think it's like a tree that kind of melded together, kind of bent down and then actually resprouted roots. So it's really, really amazing. And continue on with this tree part of the leaves and what came of this project. What's really exciting is I got to tune into a webinar of one of the geneticists we worked with just this last week. Because I left Adventure Scientists after wrapping up this field season for them. And the process of science takes a while. So I hadn't heard a ton of like, okay, we gave you the specimens you needed, now what? What happened with this? And what was really cool is Richard Crone was super excited about this work. He knew we had gotten a big sample, but when he actually got to dive into the data, he said, I've been doing this work for over 2 decades and I have never seen a collection like this. This is insanely cool. And he had this cool slide where he illustrated like, oh, here on the far left, you see one volunteer who had gotten a ton of samples. He got a good representation of what's on Vancouver Island, decent representation. But then if you add in the next top 5 high-performing volunteers, which, I wasn't a volunteer. You can see Tyson's there. That was my crazy whirlwind tour of Northern California. You start to get a sense of where bigleaf maple occurs. If you have the top 20 volunteers, you're like, wow, that's a range-wide collection. But then if you have the 110 volunteers, what's really cool is that is the range map of bigleaf maple. There's some tiny gaps in there, but you can see where the Central Valley of California is. You can see Vancouver Island. You can see the Willamette Valley. It's pretty neat. You can see where maple grows in this rough sense just by looking at where our volunteers sampled. And what's great is they were able to get the DNA they needed out of 96% of our samples. I was worried because we did a bunch of collections in September and leaf quality started to deteriorate, and I was worried that maybe some of the DNA would be compromised with other organisms' DNA, but that wasn't the case. And they now have this reference database in place. And they do know that trees from different ecoregions are genetically distinct. So they can tell these different ranges in California apart. And like I said, that Klamath Siskiyou region is distinct. Things get less distinct as you go further north and the habitat is more contiguous. And what's cool is that they are just starting to look into how this will be able to tie things to genetic origin, and they're still working on it, but they have high hopes that they'll be able to predict the location of wood samples to within tens of kilometers. So that's really helpful. You know, it won't solve every case, but you know, if I have paperwork that says, oh, this comes from Central Oregon, and the database shows like, no, it does not come from Central Oregon, then you have some evidence that could really help a court case along. And so there's this publication that's coming out. That's another benchmark of science having progressed. There'll be this publication. But I think it's worth mentioning that even if these things don't get used in court, I hope they do, but I guess another hope that I have is just folks knowing that there are consequences and there are ways to crack poaching cases. I hope that in and of itself deters some timber poaching. And now to zoom out for the last tree part, and back to the forest. You don't want to miss the tree for the forest. There's some good quote like that. So I want to zoom back out to the forest and say, it was great. We made this work domestically, but we had a couple things working for us. I'm very curious whether this will work internationally. It's worth mentioning, we only had 6 instances, I think 8 instances of misidentification, of folks misidentifying this tree. But, you know, that's because this is a very pretty straightforward species. It's like the red-winged blackbird when somebody's like, oh, what's that bird with it's black, it's red on its wing. This is similar. It's what's that maple? It's got a really big leaf. It's a big leaf maple. So we had less than a 1% error rate. Although this is a fun slide because surprise, the big leaf maple is on the left and is not the rather large California sycamore that you see on right. But yeah, so I bring that identification thing up because when you go to apply this in the tropics, or perhaps even in the eastern US, there is crazy amount of diversity and there are experts, teams of experts that can't decide on what the correct identification is. So that will be a challenge for applying this to other geographies. And similarly, we had a lot of resources to throw at this project. You know, both our volunteers coming from an area where they weren't experiencing civil unrest and had, you know, income to go on backpacking trips and like incorporate a new little scientific mission into it. And our organization had a lot of resources. You know, we automated a ton of emails using Salesforce, and we're able to use this, you know, pay to use this app, Magpie. And so that will be different in different geographies. And I think the verdict's still out as to whether this proof of concept will be super applicable to areas across the globe where it's even more relevant ecologically. But I will say that domestically, I think it has a lot of applications and it shows a lot of promise. And so I left Adventure Scientists, but they are still pushing the timber project, and they're focusing on these 3 species now. Coast redwood and western red cedar are also at risk of being poached. And Alaska yellow cedar they're looking at, because actually Alaska yellow cedar is really kind of on the decline, showing not so much resilience in the face of climate change. So they're trying to get a great sense of its genetics to write an apt and effective conservation strategy for that species. But I think this approach could apply pretty well to black walnut and black cherry, bringing things back to the Northeast. Those are species that are often snatched from people's land or public land without permit, and I think this could apply pretty well. Hawaiian koa is another domestic species that's at risk of poaching that this could be applied to. And so the story will continue to unfold as to how this proof of concept project plays out. domestically and also across the globe. And I'm going to wrap up there and just field a bunch of questions, because like I touched on a lot of things lightly, like the science behind wood identification and some best practices on citizen science and the cool place-based discussion of bigleaf maple and temperate rainforest. And I want to revisit any of those following the audience's curiosity. So thanks again.